Hello guys, welcome to a new video, and in this great new video we are going to configure OSPF and go over some OSPF's rules that we need to follow in order to form neighbor relationship. And I'm going to let's configure OSPF, and I'm going to show you how OSPF works. So this one is going to be 2. I actually want to make this one 1 over here and this one 3. Okay, so one of the other rules that we need to go over is the neighbor rule. So for OSPF to be able to form a neighbor relationship, the two routers need to be on the same subnet, right? They need to be in the same subnet. Also, they need to be in the same area because OSPF uses areas. The same hello and dead timers need to be the same between the two routers, and it needs to have the same authentication or the same shared password that you're gonna to configure. All right, so let's go ahead and work with that right now and follow those rules. And let's go to the console. This is router 3. Let's go ahead to router 1, config T. And from here, let's go and first of all, we have to go to interface fast or gigabit 0/0. Give an IP address of 10.10.10.1. No shutdown. Exit. Let's go ahead to router 2. Let's give it a host name too. Uh, there we go. Let's go back to router 1. Give it a host name of router 1. Let's go to the interface. Um, Gigabit. Which one is this one? Gigabit 0/0. IP address 10.10.10.2. Not shut down. So now from here I should be able to ping router 1. Do ping. There it is. I'm able to ping router 1. So let's make this smaller first. And let's bring the leaf pad. And let's go ahead and let's try to form an error relationship with OSPF by following these rules. So first of all, let's go ahead to router 1. Let's go ahead to router OSPF and the process ID 1. It does not need to match like EIGRP, so you can have a different number in router 2. So this is locally significant. It only makes sense in the router itself. It doesn't need to be shared with the other routers. So it doesn't, you can change this for every single one of the routers, okay? And let's go ahead and do network dot 0, and it's going to be a wildcard mask. Oops, and then after that you need to provide with the area, okay? The way the area works is they need to be in the same area. So it needs to be the same subnet and the same area. So area 0. And there are multiple areas that you could have. Um, as you can see over here, you can have from 0 to whatever numbers you could. And you can also have a IP address format. Okay, but let's leave it in 0. Now let's go to router 2. Exit router OSPF 1. Or actually, let's just do 5 for this one because it doesn't need to match. Okay, so let's go ahead and remove this one. Let's bring this one up. Network 10.10.10.0 255. And let's not follow this rule. Let's put it on another area and see what happens. Area 1. And you can see, since we did not follow the rules, we are not able to make a or form a neighbor relationship. As you can see right here, received invalid packets, mismatch area ID. So let's go ahead and fix that. And after I fix that, now that they are in the same subnet, in the same area, and the hello and the timers are the same because I have not changed any of them, and the authentication remains the same because we have not configured authentication, you can see that we have formed a neighbor relationship. Okay, so let's go ahead and configure the hello and dead timers. So if you go ahead to the interface and do IP OSPF, and you can do hello interval, and you can set it to that, which is not the default. Let's see what happens um, with a neighbor relationship. And let's also do IP OSPF dead interval and put it to 1. So since it's not, it is mismatching from router 2 to router 1, we shouldn't have a neighbor relationship anymore. So let's go ahead and, as you can see right here, it took a while, but it went down. You can see process 5, the neighbor 10, 10, 10, 1, the dead timer expired, so it came down. So since the dead timers and the hello timers are completely different from router 1, from um, the neighbor relationship came down. All right, so let's go ahead and deny those two. Let's go ahead and say no, and say no for this one as well. And then after a little bit, they should, both of them should come up. There we go. Neighbor relationship is there. So if you do show IP or SPF neighbor, it should be there. There we go. Neighbor 10, 10, 10, 1. Okay. So that is how it works, the neighbor relationship. And also another thing that I want to talk about is the DR and the DVR, or the BDR. The DR is a designated router, and the BDR is a backup designated router. And the way that OSPF works is by electing a designated router and a backup designated router. And what a designated router does is that whenever there is an update, whenever a link comes down, it sends an update to all the routers. Because in OSPF, you don't want every router to be sending mm, an update whenever something goes bad. Because let's say that we're not using a designated router, and let's say that this link comes down. What's going to happen is that since this link is going to go down, R3 is going to know that it went down, and then R3 is going to send it to R1, and then R1 is also going to notice that um, this interface is down, and it's going to send it to R3, and then R3 is going to receive that, and it's going to send it back to R1, and that's what is going to form. It's going to go back and forward between both of them, saying that it came down. Okay, and that's why we have a designated router and a backup designated router. The designated router is the only one in charge of sending updates in the network. So let's say that R3 is a designated router. What's going to happen is that if this link goes down, um, R3 is going to get that um, update that this link is down, and it's going to send it to R1 or any other routers out there, and they're going to receive it, and they're not going to forward anywhere because R3 is a designated router, and it is the only router allowed to send those updates. Okay, and the backup uh, designated router, is the one that becomes the designated router if something happens to the designated router, okay? And the way that election works is by priority, and if the priority is tied, it goes by the highest router ID, okay? And DR um, gets its updates on multicast address of 224.0.0.0 or 224.0.0.6, and then it sends all the info on multicast address 224.0.0.5, okay? And if you want to take a look at who is the DR and the BDR, we can take a look at that. But first, let's go ahead and configure R3 terminal. Let's give it a host name of R3. Oops, not R1, R3. Let's go to interface gigabit 00, IP address 10.10.10.3, 0, not shut down, router OSPF 10, network 10.10.10, 255, area of 0. Let's do the same area, guys. Exit. Now we should have a neighbor relationship. Here we go. So what I want to do is let's go and show IP. Let me see, show IP OSPF interface, and the interface is going to be gigabit 0/0. Okay, and from here you can take a look that the priority of this one is 1. Um, the router ID, designated router ID is 10.10.10.2, or or you can see that the DR, the designated router, is 10.10.10.2. And who is 10.10.10.2? 10.10.10.2 is router 2. So router 2 is the designated router. And as you can see also that the backup designated router is 10.10.10.1, which is router 1. And this actually is true because router 3 was not in that election. And since it wasn't in that election, um, we figured since it was in that election and the priority for router 1 and router 2 are 1, what 1 was the router ID of router 2, that it was higher than router 1 because router 1's um, router ID was 10.10.10.1, and for router 2 is 10.10.10.2, and it is higher than router 1. Therefore, router 2 became the designated router. But I want router 1 to become the designated router. One thing I can do is um, set the priority higher than anybody else. And to do that, you gotta do OSPF, IP OSPF from the interface, and then from here you do priority 100. Okay, and then you need to shut down the interface over here. Also, shut down the interface, and over here, shut down the interface as well. And now let's do no shutdown for all of them. Copy, no shutdown, and no shutdown. So let's go ahead and do all of them at the same time. And now that's going to do the election one more time. You can see that the interface are coming up. And show IP OSPF interface gigabit 0/0. Okay, you can see that it is still waiting. They haven't select the DR or the BDR yet, but you can see that the priority from router 1 is 100, and show IP OSPF interface And you can see the priority for this one is 1. And since this one is 1, this one is going to be the lowest, it's lower than router 1. Okay, and you can see that OSPF came up. Now let's see who became the designated router. Designated router is 10.10.10.1, which is router 1, right? And you can see over here that the state is DR, the priority is 100, and it tells you that the designated router ID or IP address is this one. The backup is 10.10.10.3. That's because since router 2 and router 3 have the same priority, but router 3 won with the highest um, IP address or router ID, okay? And that's why router 3 became the backup designator router. And like I said, that router ID, it is picked by the highest loopback address. That's how the router ID is picked. If there is no loopback address configured in the router, what's going to happen is that it's going to pick the highest IP address, right? The highest IP address configured in an interface, which is what's happening with the routers. It's not actually the highest one, but it is the only one configured in those routers, right? And just remember this, that for IPv6, you need to manually configure um, you need to manually configure if no IPv4 is being used because the router ID for OSPF v3, which is the one that we use for IPv6, if you do not have any IPv4 configured, what's going to happen is that OSPF v3, which is for IPv6, is not going to work because it won't be able to select the router ID. All right. And also here are some packets that are sent with OSPF. The first one is a hello packet that are sent to establish a relationship and also to maintain a neighbor relationship, and they are sent over time. Um, the hello timer is the default hello timer is, I believe, is 10 seconds, and the dead timer is 40 seconds or 4 times a hello packet. Okay, and then after we establish a neighbor relationship, the first thing we do is send the database description packet. Okay, that happens after we form a neighbor relationship with a hello packet, and we send the database description packet with our database in it, describing or saying all the routes that we have. And what happens is that we exchange between one another, and if router 1 does not know of a route that router 3 knows about, what router 1 is going to do is it's going to send a link state request packet, right? Like it says it right here, a router may find the parts of its topological database are out of date, right? So if router 3 knows of a route and router 1 doesn't know it, what router 1 is going to do is going to send a link state request packet, right? And then after that, router 3 is going to reply with a link state update packet. And then after that, to end it, router 1 is going to do the link state acknowledge packet. All right, so this is all for this video. I hope you guys enjoyed. On the next video, we are going to talk more about OSPF more in depth. We're going to talk about LSA, LSUs, um, LSA summary, LSA networks, and a lot of more stuff. Okay, guys, so thank you guys for watching, and I'll see you in the next one. Bye bye.